Question 13 in chapter 15 asks, what is the function of bile salts in digestion? And this has to do with digesting fats. So let's set the scene. The scene is you just ate a salad, it was doused, it was doused in olive oil, and now you have this big, gigantic glob of olive oil sitting in your stomach. Gigantic glob. And your body has to digest it. Well, it can only start to digest the parts that are exposed. So in green here, I'm gonna do the little Pac-Man, the little Pac-Man that are gonna eat this away. So you can have like one eating it here, another eating it here, another, and these would all be little proteins that would digest fat in your stomach. So they can only reach the outside. Most of this though, is on the inside, and so this is going to take a long time for your body to digest. So what your body needs to do is to break this gigantic glob up into lots of little droplets. Lots of little droplets, because if it can do that, then these little proteins can digest them much, much faster. These little Pac-Men can eat them and turn them into energy or food, whatever, can eat them really faster. So we need a way to break up the big glob of fat so that you can digest the fat more easily. Break it up into smaller droplets. And that is what bile salts do. Now, at the bottom here, I have a picture of bile salts just taken from Wikipedia. This is just a random list of bile salts. They're called bile acids here in this image because they still have the hydrogens on them. You'll notice these tails have carboxylic acids. And this is a different type of acid, but it's still an acid. So they still have the hydrogens on them, and so these hydrogens, and so that's why they're being called acids. But what can happen is those go into water, and what acids do, they give away H pluses, and then you'd have a negative oxygen there, and other sodium ions from food you've eaten would come and try to neutralize the negative charges on those oxygens. Here you have a metal and a non-metal. That's an ionic compound. And another word for an ionic compound in chemistry is a salt. So you get these bile acids producing salts, and they're called bile salts. So there are two parts to a bile salt. There are the rings. Let me just clear this for a second. There are the rings. So notice that these have the steroid nucleus, all these bile salts. Remember, the steroid nucleus are this ring structure, very specific ring structure, 3 6-membered rings, and 1 5-membered ring, this 4th one here. So these bile salts all have that steroid ring structure. And so that ring structure is nonpolar. You have a lot of carbons and hydrogens and not so many other things. So I'm going to distinguish here between the nonpolar part of the molecule and the polar parts of these molecules. And I'm going to do that with color. So the nonpolar parts I'm going to color with brown, and the polar parts I'll color with blue because they would mix with water. Okay, well, nonpolar, that's the ring structure in all of these. Now there may be 1 or 2 oxygens on these ring structures, but the vast majority of these atoms are carbons and hydrogens, and so they're nonpolar. So you get the ring structures that are nonpolar, and then you have these sort of spaghetti tails coming off the top right of these. And in each of these, they have a couple oxygens, or nitrogens, or sulfurs, really electronegative elements. And so those are all polar. So these are all polar here. Okay, so you see two parts to these molecules, a nonpolar part and a polar part. Now, what the power of this is that these molecules can form a sort of ring. They could have all of their nonpolar parts inside the ring and all of their polar parts outside of the ring. If the nonpolar parts are inside of the ring, you can fit some lipids there. And that will be able to move through water or be accepted by water because the polar parts are facing the water. And so these bile salts help to break a big glob of fat into small droplets by taking a small chunk, putting it inside one of these, and now that droplet is, this whole droplet is one of these. And the bile salts can surround another little chunk, and another little chunk, and another little chunk, until the whole glob of fat is just small little chunks that can be digested really easily. So, to put all of that into words, bile salts emulsify. Emulsification is the process of going from a big glob to lots of little droplets. So they emulsify the lipids a person eats. You're allowing this nonpolar thing to break up, or really kind of dissolve, in a polar solution like water, the water that's in your stomach. So bile salts emulsify the lipids a person eats. They break big globs of fat into little droplets that are digested more easily. Their non-polar steroid nucleus mixes with the inside of the droplets and a polar tail faces the surrounding polar water. And the whole point of that is so that you can digest lipids more easily. The organ that your liver produces bile salts and stores it in your gallbladder. And then when you eat a bunch of oil, your gallbladder will squeeze itself like a turkey baster, and all of the bile salts will squirt into your small intestines. If you eat a lot of cholesterol, cholesterol will start to accumulate. After all, cholesterol has this steroid nucleus. It's a steroid, and there's a lot of cholesterol in your gallbladder in order to make these things. These things are made from cholesterol. So cholesterol will accumulate in your gallbladder until they crystallize into stones. You'll have gallbladder stones. And then you might have to have your gallbladder removed. If that happens, then your body can't store up these bile salts anymore, and so you'd have to restrict the amount of lipids that you eat for the rest of your life, or else get severe indigestion. Because then, if you don't have bile salts, when you eat a big glob of oil or fat, it'll take a really long time for your body to digest it. And so you'll get indigestion and sort of pain in your stomach.